Alright, welcome back, ladies and gentlemen. We're looking at sections 5.4 through 5.5, day 1. I'm going to kind of do two sections together here because quite honestly they just fit together really well. Day 1 of this, with the formulas here, there's a series of formulas between these two sections, and I'll admit some are more important than others. And so we're just going to focus on the ones that are actually more important. So here we go. We're going to evaluate trig functions by hand using sum formulas, difference formulas, and double angle formulas. Okay, now before we get rolling too far here, just a couple basic questions to kind of set the stage. First of all, does sine of 30 plus sine of 60, which of course is basically saying sine of 90 degrees, equals sine of 30 plus sine of 60? So kind of like, can you distribute the sine, so to speak? Alright, well, sine of 90 degrees, let's verify whether or not this is true. Sine of 90 degrees, well, of course, that's equal to 1. Alright, well, let's see if that's equal to sine of 30. Well, let's leave sine of 30. If I reference my unit circle here, sine of 30 ends up being a 1/2, and sine of 60 ends up being root 3 over 2. Okay, now, well, 1/2 plus, well, if it was 1/2 plus 1/2, that would actually be equal to 1. But obviously, root 3 over 2 is not a half, so basically, that's a big fat no. Alright, so basically we can't distribute the sine function. So basically we need some other way around that in case we were trying to add two angles together. Wink, wink, nudge, nudge. We have a sum formula in the works. Alright, additionally, how about this? What if sine of 2 times 45 degrees, is that equal to basically like factoring out the 2? Okay, so can we do something like that? Again, 2 times 45 is still 90, so sine of 90 is still equal to 1. And then 2, let's see, sine of 45, again referencing my unit circle, I get root 2 over 2. And, well, let's see, well, let's go this way instead. Okay, the 2 with the 2 cancels here and just leaves us the root 2. Well, 1 pretty much isn't equal to root 2, so again, that is a big fat no. Okay, it doesn't work, so we need some other way around that as well. And again, we have a double angle formula that's going to handle that. Hopefully you can kind of take on faith here that the difference that I didn't demonstrate here is going to be equally bad as far as doing an example like this. So we're going to need some formulas, and let's start digging into them. Alrighty, so here are the sum and difference formulas. We'll get to the double angle formulas later, and quite honestly I'm just going to flat out give you these, because quite honestly their derivations are fairly messy in some cases, so I'm not going to show you where they come from, and just hopefully you can kind of take it on faith. But anyway, here it is. There is actually a new symbol here in this mess of stuff. But sine of u plus or minus v is sine of u cosine of v. So notice u is my first angle and v is my second angle. So just sine of the first times cosine of the second, and then plus or minus. Okay, again, the plus or minus here with the plus or minus here basically means if I'm adding, I'm going to use the plus, and if I'm subtracting, I'm going to use the minus. So basically the top corresponds to the top and vice versa. Alright, so sine, cosine, cosine, sine, 3.14159. Woo! Sounds like a nice cheer, doesn't it? Anyway, that's that formula. Hopefully that makes it easy to remember, and that will haunt your dreams for the rest of your life. Alright, then cosine here. Okay, we've got a plus or minus here. Notice in the formula I've got a minus plus. Okay, so that's a little bit dicey, but basically again what it means is the plus goes with the minus, and then the minus goes with the plus. Okay, the way I like to remember this thing is that sine stays the same with its plus or minus, and the cosine changes with its plus or minus. And notice that same starts with S and change starts with C, so ooh, maybe there's a way to remember it. Okay, but whatever works for you. There's the formula. Hint, yes, I want you to memorize these. And then we've got a tangent formula, and okay, basically the same idea. That here's this formula, plus or minus, and then notice on the bottom it's minus plus. So again, these signs are always going to be opposites. You're either adding or subtracting on top, and then you're either subtracting or adding on the bottom with this multiplication here that's going on. But again, I think I've babbled on long enough, but there you go. Get them, use them, need to have them memorized. Alrighty, now let's take a look at a tangent problem using one of those formulas. We're going to use radians again, because it's maybe a little less obvious in degrees, but whatever the case, let's go. Alright, so if I've got tangent of 4 pi over 3 plus pi over 4, okay, again, our basic tangent formula is going to be tangent of the first angle, so we'll call it u, and plus tangent second angle v, all over 1 minus the product of those two tangents, so tangent u times tangent v. Okay, so before I start plugging things in, I need to take a look at my unit circle values here. So let's do that. Okay, 4 pi over 3 is going to land us in the third quadrant, right there is our pi over 3 reference angle. So just for clarity's sake, this is going to be a negative 1/2, then negative root 3 over 2 as far as my angle measures. And then the pi over 4, it's a nice first quadrant angle, it's a little bit nicer, and again, as far as values, it's root 2 over 2, root 2 over 2. Okay, so the tangent of the 4 pi over 3, alright, so tangent 4 pi over 3 plus tangent pi over 4, okay, and that's going to be all over 1 minus tangent, again, same exact two angles, 4 pi over 3 tangent pi over 4. Okay, now this does get a little bit messy because we're going to end up having fractions inside of fractions here, but, or at least potentially. Okay, well now, tangent pi over 3, 4 pi over 3 rather, I need the y over the x, so I get negative root 3 over 2 over the 1/2, negative, so that, in this case at least, very nicely works out to be a root 3. Alright, so basically I've got a root 3 plus tangent pi over 4, well that's just root 2 over 2 over root 2 over 2, so that's 1. Okay, and the denominator has the same sort of thing, 1 minus, and again the product of these two things, which is very conveniently just the product of these two guys up on top, so it's really just root 3 times 1. Alright, so this one doesn't work out terribly, but root 3 plus 1 over 1 minus root 3, and you kind of make a decision here about how to deal with things, because honestly 1 minus root 3, it's kind of awkward having these things not lining up well. So either arrange it so both the roots are first or both the regular numbers are first, whatever the case holds. Because of the way the denominator looks, I'm going to take the numerator and flip it around to 1 plus root 3 and put it over 1 minus root 3. Okay, from there we'll rationalize this guy, 1 minus root 3 top and bottom. Sorry, 1 plus root 3 top and bottom. Okay, and so multiplying things across. Okay, on the top I'm going to get a 1 plus, I'm going to get a root 3 plus a root 3 again, plus root 3 times root 3 is a 3. And on the bottom I've got 1 minus, okay, basically again the OA cancels from FOIL, and gets me a 1 minus 3 basically. Okay, so just kind of come over here to the left now. Alright, so on top I've really got 4 plus 2 root 3, which isn't completely ridiculous. And in the denominator I've got something fairly nice as a negative 2. Alright, so basically as we get a total final answer here, by reducing everything by negative 2 gives me a negative 2 for my first term here, and then reducing the negative 2 with this gives me a negative root 3. And that would be our final answer for that. So it is a little bit of work, but that's how you can do it. Alrighty, let's move on to something where it's not quite so blatantly obvious staring us in the face what two angles to use. Okay, first of all, let's take one in degrees, cosine at 285 degrees. Well, okay, now again, degrees are a little bit easier to kind of work with in your head. Okay, so I've got to split this, as it says over here, to determine two nice angles, so again, our unit circle values that we can add or subtract to get the given angle, because 285 certainly isn't one of the nice angle measures that we're usually working with. Okay, honestly, the approach I like to go with is use a first quadrant angle and kind of peel that off, if you will, and then use, you know, kind of the leftovers and see what that gives you. Okay, so for instance, okay, big hint here, this ends in 5. So I'm going to kind of peel off a 45 and then see what's left, and by taking off 45 degrees, that leaves me with 240 degrees. Okay, so at basically this point, and for time constraints in the video, basically you plug this into the formula, work out the various unit circle values for the 45 and the 240, and just for, you know, argument's sake here, of course the 45 degrees is pi over 4, so it's going to give you there. The 240, well remember this is 180 flat, and then that's another 60 degrees short, so it ends up being kind of the pi over 3 reference angle by right there. So as that's kind of our pi over 4, also known as 45 degrees. Okay, this guy over here, the 240 degrees, ends up being basically 4 pi over 3. And then you basically plug the various x and y values from the unit circle in there, and eventually, I'll leave this to you, so you don't have to watch me do this for too much, this works out to be negative root 2 plus root 6 all over 4. Okay, of course, if you want to see the work, please ask me in class. I'll be happy to do the whole thing there. But for the sake of the video here, I'm just going to say, there you go. Okay, doing radians, of course, is a little trickier because, quite honestly, our brains don't like fractions as well as the whole numbers here with the degrees. Okay, so basically a little bit of guess and check might be necessary. But here I go. I got something that's got a denominator of 12. Okay, well, if I've got a denominator of 12, okay, it might be nice to work with something with denominators of, let's say, 3 and 4, which are two, you know, pretty standard measurements in the unit circle for radians. Okay, so what you maybe do is go off to the side, do a little bit of guess and check here, and say, well, I need to subtract. Well, let's do this. Since it's negative, I'm thinking I should subtract. And so I want to subtract and get a negative answer, so I need to do kind of a small minus a big. So again, denominator of 12 probably needs a pi over 3, and then a pi over 4. Okay, now pi over 4 is the smaller of those, so I'm going to try pi over 4 minus pi over 3, and see if that gives me the desired result of negative pi over 12. And well, a little bit of common denominator work gives me a 3 pi over 12 minus 4 pi over 12, and lo and behold, I do have the negative pi over 12 that I wanted. So basically, back here, I'm going to rewrite the sign of negative pi over 12 as sine of what I just guessed over there, pi over 4 minus pi over 3. Okay, now I'm not expecting you to always guess right the first time, but I guessed right the first time here just to demonstrate how it would work, and I'm sure you didn't want to see me do a bunch of wrong guesses in the video. Again, if you want to see me actually work this out now, definitely grab me in class, but if you'd like to just pause this and work it on your own, give it a shot, what this should work out to be is root 2 minus root 6 all over 4. And you might be thinking, hey, that looks a lot like the last answer, and you're right, it is, and there is a good reason for that. But again, I'm going to let you see if you can figure that out instead of just plain giving that to you in the video. Alright, let's keep moving on. Okay, so in working with the formulas more, just getting used to them, okay, there's some good problems here about evaluating, which is technically what we've already been doing, but based on non-unit circle type values. Okay, so if I want cosine of u plus v, and I know that sine is negative 8/17, cosine of v is 3/5, and then both of those two angles are in quadrant 4. Okay, so what I like to do in a situation like this is just draw two separate triangles, and then based on those two triangles I can pull whatever values that I need from them. So here we go. So triangle U, again, I'm going to be in quadrant 4, so I'm just going to purposely draw a very quadrant 4 heavy graph here. Okay, and I know that sine of U is going to be negative 8/17, so I know that's going to be opposite over hypotenuse. So my opposite is going to be a negative 8, my hypotenuse is going to be 17, and hopefully you recognize the Pythagorean triple there as 8, 15, 17. So basically there's my angle U diagram, triangle, whatever you want to say. Okay, and then I got another one that I'm going to do for V, again quadrant 4, so I'm going to draw a very quadrant 4 heavy graph, and then the cosine being 3/5. Now again, hopefully you recognize those particular arrangement of numbers, but adjacent over hypotenuse, so my adjacent is going to be a 3, my hypotenuse is going to be a 5, and again, hopefully not too shockingly, that gives me a 4, technically a negative 4 though. That's my opposite side. So basically there's all I have, and I want cosine u plus v, so again cosine u plus v. Okay, for those of you with really, really bad handwriting, and I'm one of those people, sometimes the u's and v's might look similar, so if you want to scrap the u and v and use different letters to help differentiate what you're trying to do, then I encourage that. Okay, but here we go. So cosine v, again, the basic formula just simply says I want cosine u, cosine v, and then again remember plus using minus right here, and then the sine of each, sine u, sine v. Okay, and then basically again just kind of pull the various values that you need off of the triangle diagrams. So cosine u is going to be 15 over 17. Okay, cosine of v, well, hint, we already had that, but in case you figured off the diagram either way, 3/5 minus sine of u. If you go over here, it's negative 8/17. Again, we actually did have it, but there you go. Negative 8/17 times sine of v. So coming over here, I got negative 4/5. Alright, and then just kind of basically crunch the numbers here. There's not much to go here, so I'll do it. So I got 45 over 85. Okay, notice I'm not trying to cancel anything because looking at 17 and 5, 17 and 5, I know I've got common denominators already, but if I start reducing stuff, maybe I lose that, so I'm purposely not going to do so. Okay, I've got 3 negatives, so actually that still leaves a negative result, and 8 and 4 gives me a 32. I still got my 85, which again is nice and happy and cheerful. Okay, and then just 45 minus 32, pulling out my abacus. Quickly that lets me know that that's 13 over 85. So basically we can do this if we're given triangles and not unit circle values just as well. Okay, now nobody freak out. If you're asked to do cosecant, you might be like screaming, oh my gosh, there's no cosecant formula, what are we going to do? Well, okay, instead of lighting your hair on fire and diving out a window or something crazy like that, just kind of slow down, take a deep breath and say, oh, wait a minute, cosecant, well, all I have to do is figure out sine, and now I have to just flip it over. Okay, so basically I'm not going to spend the whole time to do this because, quite honestly, this video is going to be long enough as it is, but basically, just as a hint, find sine of u minus v, then flip the result. Okay, so if you see one of the non-SOHCAHTOA trig functions, don't panic. Do the appropriate reciprocal one and then just flip it over when you're done. Okay, this brings us to the double angle formulas. Okay, now, these are technically the start of section 5.5 now. But, okay, you might be like, hey, you big cheater, you're making us do too much, but, you know, get over it. Okay, if we're going to rewrite these using the angle sum formulas, okay, basically, a double angle, well, u plus u is the same thing as 2u. But all you got to use is these formulas that we have been using for the rest of this video. Okay, sine of u plus u, again, is sine, cosine, cosine, sine, etc. It's a nice cheer one. So, sine of u, cosine u. Alright, and then again, you keep the same sign, and then it's going to be, whoops, cosine u, sine u. Alright, well, sine times cosine, and then cosine times sine, but notice the angle u is the same all the time, so actually we have like terms here. So I have one of these things plus one more of those, so it actually works out to be two of those. Alright, so basically the double angle formula is simply taking the sum formula and kind of using the same angle both times, and you come up with something like that. Alright, for cosine, it's going to be kind of the same thing, although there's a little bit of a twist to this one, because the cosine formula says cosine cosine, and then again, this gives me a minus now, sine sine. Okay, so really what we have here is cosine squared u minus sine squared u. Okay, and I'll give this on the next slide, but basically because of this, having these squares, I can replace one with the other, plus or minus having that one involved, and simplify that down. So basically here's one form of the equation, and depending on the scenario, I have two other forms I could use if I wanted to. Okay, so I'll just have a little etc. with a smiley face next to it. But again, I'll show that later. Same basic argument for tangent. Tangent, we're going to work that out to be tangent u plus tangent u. Okay, again, the tangent formula, you keep the same sign on top, and you do the different sign on the bottom. Okay, 1 minus tangent u. Alright, and for space concerns, I'm going to go horizontally here, but basically notice on top I have the same thing twice, so that'd be 2 tangent u over 1 minus, well, tangent times tangent gives me a tangent squared, because I'm using the same angle both times. So basically that's how that formula goes. Alrighty, so basically in summary from all that stuff I just did, cosine 2u, again using those angle sum formulas, we can actually get a nice quick formula, 2 sine u cosine u for that. Cosine 2u, we can get cosine squared u minus sine squared u, is the one I showed, but again using a little bit of Pythagorean replacement and substitution and manipulation, we can get either 2 cosine squared minus 1 or 1 minus 2 sine squared. Alright, and then finally for tangent, it is the one that I did, where you get 2 tangent u minus, over 1 minus tangent squared. Alright, so again, those are nice to have memorized, but again, as I just did, you could derive those if you absolutely had to. Okay, so just hopefully one semi-quick example of how these things get used. Alright, so let's say here's a triangle that I've got, and I got my nice angle theta in there, but if I wanted to know what cosine of 2 theta was, okay, well again, I can't just figure out cosine and then double it. Okay, because a twice as big angle doesn't necessarily mean twice as big as a value when you figure out the various trig functions. Okay, so anyway, first thing first, if I've got two sides of a right triangle, kind of almost automatically, it's a good idea to figure out the third side. So 25 when I square that guy, 4 when I square that guy, subtract them, I get root 21. Okay, so now I've got my cosine formula, and again, I've got 3 different variations I could use. So cosine 2 theta, just for the sake of argument, I'm going to go with kind of the original, the squared version, or the double squared version, if you will. So I want to do cosine squared theta minus sine squared theta. Okay, and again, that isn't equal to 1. If that was a plus sign, yes, it'd be equal to 1, but since it's not, it's not. Okay, so then just got to figure out my cosine. Cosine is root 21 over 5, so that sounds fun. Root 21 over 5, and that's going to be squared. Minus my sine value is going to be 2/5. And again, I'm just going to square that. Yeah, it's just a matter of crunching the numbers, and this should go pretty quickly. We got 21 over 25. Don't forget to square the denominator. That's a common error. And now I've got 4 over 25. Okay, and simply subtracting 21 minus 4 gives me about 17. You might want to check that with your calculator if you're not sure. And so that gives me 17 over 25. And there you go. Of course, I could ask for the other two, but I'm sure you don't want to spend any more time watching this video. Alrighty, I thought I'd pair up one of your most favorite words with some of your least favorite things here on this particular slide. Okay, so here's the assignment of the 2 different page numbers, and I used enough for everything. Some of these get a little redundant, so fine. Make sure you got the hang of it. Again, enough is not none for anybody, so don't even think it. Okay, and then, of course, your least favorite word, memorize. Put on one of maybe your least favorite people's chests, actually, even if you've ever been to American Idol. I'm guessing nobody has, though. But anyway, there it is. Have those formulas memorized. Very, very important. There's the assignment. I'll see you in class.